Welcome to AICTE PRERANA scheme for preparing SC/ST students for higher education GATE. So, Erode Sengunthar Engineering College jointly organized AICTE PRERANA scheme for preparing SC/ST students for higher educations. So, I am R.KRISHNASAMY, Assistant Professor, Department of Civil Engineering, Erode Sengunthar Engineering College, Tamil Nadu. So, I am going to handle under the section 4 in your GATE syllabus, Water Resource Engineering. So in this section, I am going to handle the subject fluid mechanics under the topics fluid statics. So what are the topics we are going to discuss in this session is fluid statics, hydrostatics law, Pascal's law, atmospheric pressure, absolute pressure, gauge pressure, and vacuum pressures. So what is meant by fluid statics? We know that fluid is a water, water, then milk, kerosene. These are the we call this commonly called as a liquid and air. So liquid and air we call it as a fluids. We already discussed in the fluids and fluid properties. So what is meant by statics? So this topic deals with the fluids at rest. So we are considering a fluid in a rest position. We are going to study the behavior at the rest position. We call it as a statics. So at the time there will be no relative motion between adjacent or neighboring fluid layers, and also velocity gradient and shear stress are to be zero. So consider a fluid is static at one position in any medium. There is a no movement, and also there is a no velocity, and we call it and then we have a no shear stress between the fluids and the medium. So that's why in this topic considering in the fluid statics, velocity gradient and shear stress are to be zero. Then the force. So force is nothing but pressure in the area. So acting on the fluid particles will be considered due to pressure of fluid normal to the surface. Then due to gravity, that is a fluid is static in one position. So at the time, whole body weight will be acting towards the downwards. So we are considering self weight of the fluid particles. Then Pascal's law. So what is meant by Pascal's law? It states that the pressure or intensity of pressure at a point in a static fluid is equal in all directions. So consider this is a wedge, irregular shape of wedge. The fluid particles is considering all the directions. That is a pressure at x direction, pressure at y direction, pressure at z direction, which is acting towards the that point F or the center of that particular medium objects. The summation of px, py, pz, which is equal to 0. So that's why here at a point in a static fluid is equal in all the direction. So that's why this is called Pascal's law. So then now we are going to discuss about what is meant by atmospheric pressure, absolute pressure, gauge pressure, and vacuum pressures. So the pressure on a fluid is measured in two different systems. So in one system, it is measured above the absolute zero or complete vacuum, and it is called absolute pressure. What is the other system? Pressure is measured above the atmospheric pressure, and it is called gauge pressure. So we have to keep it in mind. First pressure system is absolute pressure, another system is gauge pressure. So I will show you here then picture pressure representation of what is atmospheric pressure. It will be easily understand the concept of the pressures. So atmospheric pressure, also known as barometric pressure, is the pressure within the atmosphere of Earth. So the standard atmosphere is a unit of pressure defined as 101,325 Pascal. So here Pascal, which is a unit for a pressure, so which is equivalent to 103.3 kilonewton per meter square. So it is we frequently asking in your grade questions. So what is the conversion factor from Pascal to the kilonewton per meter square? So note it down. Or they can mention in terms of Newton per centimeter square in SI unit, that is 10.13 Newton per centimeter square. So another system 1.033 kgf per centimeter square in MKA system. So which is already we have discussed in the fluid properties, which is MKA is meter kilogram seconds. So kg is weight, F is the force, then centimeter square is the seconds. So the mass. So mass we mentioned in the kg, length we measured in the meter or centimeter. The atmospheric pressure head is 760 mm of mercury or 10.33 meter of water. This is the very important one. So note it down. The atmospheric pressure head is 760 mm of mercury or 10.33 meter of water. So see the diagram here. So this is the sea level. So at the sea level we mentioned as a one atmospheric pressure of, that is 14.7 pounds per inch square. So here we are considering the pressure is high. When go for a higher altitude, the pressure will be low. So see the pictures here. So lower altitudes having a higher pressure, higher altitudes having a lower pressure. So note it down quickly. So then we can easily differentiate here by the bar chart, bar diagram. So there is a line here we considering as a absolute zero pressure here. Then here blue line is mentioned as the atmospheric pressure. So after here from the reference of absolute zero pressure, we measured as the absolute pressure here. So over the green line, we, we called as a vacuum pressure. So over the atmospheric pressure, we measured in terms of gauge pressure. So here atmospheric pressure plus gauge pressure, we call it as a absolute pressure. So here we mentioned in terms of the sign. So vacuum pressure we always mention in terms of zero atmospheric pressure. So P equal to 0. So over the vacuum we measured in terms of atmospheric pressure. In case of below the atmospheric pressure, we mentioned as a negative gauge pressure. Above the atmospheric pressure, we mentioned as a positive gauge pressure. The summation of atmospheric pressure plus gauge pressure we called as the absolute pressure. So these are the different pressures measured above the datum line. So above the vacuum we mentioned as a atmospheric pressure. So over the atmospheric pressure we measured as a gauge pressure. The summation of atmospheric pressure plus gauge pressure we mentioned as a absolute pressure. So note it down. Draw the diagram clearly, then only you can easily understand. The frequently it will be asking in gate objectives. So note it down. Then we will see one by one. So absolute pressure. So pressure which is measured with reference to absolute vacuum pressure. So that's the word is very important. The pressure which is measured with reference to absolute vacuum. So we remove all the pressures we mentioned as a vacuum, whereas there is a no, there is a nil, so, or we call it as a zero. That's that term absolute will be used. Absolute pressure which is equal to the summation of atmospheric pressure plus gauge pressure. So in a region such as outer space, which is virtually void of gases, the pressure is essentially zero. Such a condition can be approached very nearly in a laboratory when a vacuum pump is used to evacuate a bottle. The pressure in a vacuum is called absolute zero, and all pressures referenced with respect to this zero pressure are termed as absolute pressure. So when we take one glass bottle, so it having some pressure into that, so we need to remove that pressure from the bottle by using the pump. So after removing, we mentioned as that absolute zero. So we considering that is the point we call this absolute zero. So after that, whenever we measuring that pressure, we call this absolute pressure. So after excavating all the pressure into the bottle, we measured the pressure, we call this absolute pressure. Then we go for our next pressure is gauge pressure. Gauge pressure, which is measured with the help of pressure measuring instrument, in which atmospheric pressure is taken as datum. So previous case we are taken as a absolute vacuum. Here we considering the atmospheric pressure is a datum. So atmospheric pressure on the scale is marked as zero here. So many pressure measuring devices measure not absolute pressure, but only difference in pressure. So for example, take a considering example, board-on tube gauge indicator indicates only the difference between pressure in the liquid to which is tapped and the pressure in the atmosphere. In this case, the reference pressure is actually atmospheric pressure. This type of pressure reading is called gauge pressure. Then vacuum pressure. So vacuum pressure below the atmospheric pressure. The formula is atmospheric pressure minus absolute pressure. So atmospheric pressure is used as a reference. The possibility exists that the pressure thus measured can be either positive or negative. So negative gauge pressure also known as vacuum pressure. So note it down. These are the terms which is frequently asking in the GATE syllabus. So every term you have to be recollected. So here negative gauge pressure also termed as vacuum pressure. Shall we go the next? Okay. Measurement of pressure by various types of manometer. So far we have discussed about the what is meant by what is pressure, what is fluid statics, what is Pascal law, what is different types of pressures, absolute pressure, gauge pressure, vacuum pressure. So all the pressures we have discussed. Now we are moving into the next topic, measurement of pressure by various types of manometer. The pressure of a fluid is measured by the following devices. Number one, manometers. Number two, mechanical gauges. So we go for a differentiate between what is manometers and what is mechanical gauges. The device used for the measuring pressure at a point in a fluid by balancing the column of fluid by the same or another column of the fluid. The example, simple manometer, differential manometer. So then what is mechanical gauges? The device used for measuring the pressure by balancing the fluid column by the spring or dead weight. Spring or dead weight. So number one, diaphragm pressure gauge. Number 2, Bourdon tube pressure gauge. Number 3, dead weight pressure gauge. Number 4, bellows pressure gauge. So once again I repeat it, note it down. Mechanical gauges. Number 1, diaphragm pressure gauge. Number 2, Bourdon tube pressure gauge. Number 3, dead weight pressure gauge. Number 4, bellows pressure gauge. So we will see one by one what is meant by simple manometers. So it is consist of a glass tube having one of its ends connected to a point where the pressure is to be measured and the other end remains open to atmosphere. Yeah, considering a fluid pipe, there is a glass tube is fitted on a pipe. So whenever the water is flowing, there is a difference which is showing in the that tube. So what are the common types or simple manometers is first one piezometer, number 2 U-tube manometer, number 3 single column manometer. So first we will see piezometer. So it is used for to measure the gauge pressure. The formula is rho into G into H. So consider A is the pipe. So this is the glass tube. The flow of water is flowing into the pipe A. So water also is flowing in the piezometer tube at a specific height of H. So we are considering density of the fluid, that G acceleration due to gravity, the H the rise of liquid in piezometer glass tube. So whenever they are asking for a question to finding the gauge pressure by using piezometer, we have to use the formula rho into G into H. So rho is the density of the liquid, G acceleration due to gravity, H rise of liquid in piezometer. So unit is Newton per meter square. The next U-tube manometer. So it consists of glass tube bent in U shape. So look into this picture. So here considering the tube which is having a shape of U. One end of which is connected to a pipe point at which pressure is to be measured and the other end remains open to the atmosphere. So which is having U shape, the left limb which is connected to the pipe, the right limb remains open to the atmosphere. The tube generally contains mercury or any other liquid whose specific gravity is greater than the specific gravity of the liquid whose pressure is to be measured. So if you want to measure the pressure into the pipe, we need to use the density is or specific gravity which is greater than the liquid which is flowing into the pipe. So B is the pipe. So we are considering the liquid which is taken for the measurement of pressure, either mercury or highest specific gravity fluid. For left side picture showing that the left limb which is below the section AA, the right limb above the section AA. So left limb we considering the height is H1. The right limb, the height of that mercury we considering is H2. So this kind of the left limb picture shows that for measuring the gauge pressure. At the condition of gauge pressure, we may using that like that it will be showing. For the second one, vacuum pressure, that picture shows in the right hand side. The left limb of the YouTube manometer, the mercury will be raised towards the left limb. That is a H1. We considering the height of the fluid of flowing in the pipe, whereas H2 from the datum line AA, we considering H2. The H2, the height of rise of mercury in the limb. So there is a two cases. Case one for the measurement of gauge pressure. For the case two, vacuum pressure. So draw the diagram quickly. Sometimes they given a diagram in your gate exam. They will ask about question. We need to use the apply the formula. We have to find in the what kind of pressure we have to measure from this gauge pressure or vacuum pressure. The next single column manometer. Single column manometer. It is a modified form of YouTube manometer in which reservoir having a large cross-sectional area as compared to the area of the tube is connected to one of the limbs of the manometer. So it is a similar one, YouTube manometer, but it is a modified. So it is applicable only for a large portion of water, kind of a reservoir. So due to large cross-sectional area of the reservoir, for any variation in pressure, the change in the liquid level in the reservoir will be very small, which may be neglected, and hence the pressure is given by the height of the liquid in the other limb. We are considering the vast area, so that's why we are neglecting the very small height rise in the tube. So another limb may be very either in vertical or in inclined position. If we are considering the vertical position, if we are considering inclined position, we have to resolve it for vertical, then we calculate the formulas, and then by using formulas we finding the pressures. What are the two types? Number one, vertical single column manometer. Number two, inclined single column manometer. So this diagram is vertical single column manometer. So one of the limbs in double column manometer is converted into reservoir having large cross sectional area, about 100 times with respect to the other limb. The formula is volume of heavy liquid all in reservoir, volume of heavy liquid rise in right column, A into del H, which is equal to A into H2. So here considering del H is the difference. So A into H2 by capital A. So pressure in left column to the pressure in the right column. So we considering left and right also we have to equating. So after equating we are getting pressure equal to rho 2 G H2 minus rho 1 G H1. An inclined single column manometer. So previous case we are discussing about the vertical. Here there is an angle inclined by an angle. So we have to resolve it. Then we have to finding the pressure. So it is a modified of vertical column manometer. This manometer is useful for the measurement of small pressure. Here height we are considering H2 is equal to L into sin theta. So look at this picture. So L in the inclined position. So inclined distance. So here we are considering the opposite side by hypotenuse. So resolve it. We will get the H2 equal to L into sin theta. Substitute here P equal to AL sin theta by A, capital A, rho 2 into G minus rho 1 into G plus rho 2 GL sin theta minus rho 1 GH1. So we are considering small a which is far greater less than the capital A. So we are neglecting the first term. So not only the first term we are neglected. So remaining term is rho 1 rho 2 G L into sin theta minus rho 1 G H1. So after resolving that equation, we get it H equal to S2 L sin theta minus S1 into H1. So considering this is the assignment, so it is a continuous of previous gate coaching. So note it, you take it as a assignment. Explain in details about the following questions. Number 1, absolute pressure. Number 2, gauge pressure. Number 3, atmospheric pressure and vacuum pressure. The second assignment question, distinguish between manometers and mechanical gauges. What are the different types of manometers? So we will solve some of the problems which is frequently asking in the gate. So I read out the questions. What are the gauge pressures and absolute pressure at a point 3 meter below the free surface of a liquid having a density of 1.53 into 10 to the power of 3 kg per meter cube if the atmospheric pressure is equivalent to 750 mm of mercury? The specific gravity of mercury is 13.6 and the density of water is 1000 kg per meter cube. First you need to write what are the data is given. So depth of the liquid is given, Z1 equal to 3 meter. Density of liquid rho 1 equal to 1.53 into 10 to the power of 3 kg per meter cube. Atmospheric pressure head Z0 equal to 750 mm of Hg. Hg is here mercury. So here they given in terms of mm. So convert in terms of meter. So divided by 1000. So 750 divided by 1000 which is equal to 0.75 meter of mercury. Atmospheric pressure. So P suffix ATM which is equal to rho 0 into G into Z0 where rho 0 equal to density of mercury equal to 13.6 into 1000 kg per meter cube, which is the value which is already we know that mercury 13.6 specific gravity. So Z0 which is equal to our pressure head in terms of mercury. Now finding the atmospheric pressure. 13.6, that is specific gravity of the mercury, into 1000. So here 13.6 into 1000 is considering as the density, into G is the constant value 9.81, into H value 0.75 meter. So multiply all the values, you will get 1,000,62 Newton per meter square. So what are the finding in the question is gauge pressure and absolute pressure. So first finding the gauge pressure at a point which is at a depth of 3 meter from the free surface of the liquid is given by P equal to rho 1 into G into Z1. So here our finding density is 1.53 10 to 3. So substitute the value into 9.81 into 3 meter below. So final value is 45028 Newton per meter square. Then absolute pressure, we know that formula gauge pressure plus absolute pressure. So value, substitute the value here, 45028 Newton per meter square plus 1,000,62 Newton per meter square. The final value is 1,45090 Newton per meter square. So note it down quickly by giving a time. This is a very basic problem. And then I highlight the answer also.
Yes, sir. Space பண்ணுமாப்பா.
So YouTube manometer, note down the formula. So note down the question. The right limb of a simple YouTube manometer containing mercury is open to the atmosphere, while the left limb is connected to the pipe in which a fluid of specific gravity 0.9 is flowing. The center of the pipe is 12 meters below the level of the mercury, the right limb. Find the pressure of fluid in the pipe if the difference of mercury in the two limbs is 20 centimeter. So this is the problem which is asking from YouTube manometer. So considering YouTube manometer, so right limb which is filling by mercury, the right limb is which is open to the atmosphere, the left limb is connected to the pipe, the fluid precipitate is 0.9. The center of the pipe is 12 centimeter below the level of the mercury. So difference also given 12 centimeter below, and then also mercury level between the two limb is 20 centimeter. What are the data is given? Specific gravity S1 is 0.9. Density of the fluid, specific gravity into 1000, you will get the density 0.9 into 1000, 900 kg per meter cube. Specific gravity of the mercury S2 is 13.6. Density of the mercury rho 2 equal to 13.6 into 1000. Difference of mercury H2 equal to 20 centimeter. So convert in terms of meter. 0.2 meter. So we are going to equating the pressure. So P plus rho G H1 equal to rho 2 G H2. So P plus rho is density. So 900 he is given value 900 into G is the constant value 9.81 into H1. So left limb. So left limb which is having a not a direct value. So the given right limb 20 centimeter, the difference is 12 centimeter. So 20 minus 12 will get the 8. So directly they are substituting here 0.08. So P equal to 13.6 into 1000 into 9.81 into 2. We get the rupees 25,977 Newton per meter square. So we go for another problem. A simple YouTube manometer containing mercury is connected to a pipe in which a fluid of specific gravity 0.8 and having vacuum pressure is flowing. The other end of the manometer is open to the atmosphere. Find the vacuum pressure in pipe if the difference of mercury level in the U2 limbs is 40 centimeter and the limb height of fluid within the left and the outer pipe is 15 centimeter below. So note down the given data. What are the data is given? Specific gravity of fluid is given 0.8. Specific gravity of mercury is 13.6. Density of fluid 800. Density of mercury 13.6 into 1000. The difference of mercury level H2 is 40 centimeter, that is 0.4. Height of the fluid in left limb H1 equal to 15 centimeter. Let the pressure in pipe P equating the pressure. Opposite datum line AA we get rho 2 GH2 plus rho 1 GH1 plus P equal to 0. So P equal to minus. So keep it in pressure in left hand side. So bring the other terms to the right. So minus of rho 2 GH2 plus rho 1 GH1. 13.6 into 1000 is 9.81. So 53366.4 plus 1177.2. So finally we get 54543.6 Newton per meter square. So minus of 5.454 Newton per centimeter square. So this is the problem for single column manometer. So consider these are the assignment number 5. So note down all the questions and submit it as assignment number 5 in the pressure measurement topic. So number 1, determine the gauge and absolute pressure at a point which is 2 meter below the free surface of water. Take atmospheric pressure as 10.1043 Newton per centimeter square. Question number 2, a simple manometer is used to measure the pressure of oil, that is specifically equal to 0.8, flowing in a pipeline. Its right limb is open to the atmosphere and the left limb is connected to the pipe. The center of the pipe is 9 cm below the level of mercury in the right limb. If the difference of mercury level in the two limbs is 15 cm, determine absolute pressure of the oil in the pipe in Newton per centimeter square. Question number 3, a simple manometer containing mercury is connected to a pipe in which oil of specific gravity 0.8 is flowing. The pressure in the pipe is vacuum. The other end of the manometer is open to the atmosphere. Find the vacuum pressure in pipe if the difference of mercury level in the two limbs is 20 cm and the height of the oil, the left limb from the center of the pipe is 15 cm below. The answer for this question is minus 37.86 Newton per centimeter square. A single column vertical manometer, that is micrometer, is connected to a pipe containing oil of specific 0.9. The area of the reservoir is 80 times the area of the manometer tube. The reservoir contains mercury of specific 13.6. The level of mercury in the reservoir at a height of 30 centimeter below the center of the pipe, and the difference of mercury level in the reservoir and the right limb is 50 centimeter. Find the pressure in the pipe. So you have to complete your assignment 3 and 4 and 5. So we will see on the next gate coaching videos. So before that, I request everyone to submit the assignments. We will discuss in the next class for the next topics. So thank you all.